And we are live on Siren Sundays. Welcome everyone to another edition of Siren Sundays. This is season 3, episode 5, and my lovely guest today is Dr. Will Gustave, and he's going to be talking about what's in our soil and how it affects food quality. So I'm going to give you guys a few minutes to hop on, tune in, and in the meantime, I'm going to quickly show everyone a gift that I recently received that it's going to be hard to see this based on like the reflection, but thank you, Dr. Deandra Milford Delancey, or Delancey Milford, I just messed up her whole last name, for this gift with my logo. I love it. She is my bestest friend ever, and I'm so happy to receive this from her. Always find people in your life who are going to support your dreams, guys. So we have a couple of viewers on. I'll give it like 10 more seconds. I see we have some comments. If you guys are out there and you're watching us, let us know where you're from, maybe why you tuned in today to listen to our talk about soil. And I feel like I was telling you earlier, it's definitely going to be a lot of people, COVID had a lot of like people decided they wanted to start planting. So we're going to have a lot of people on here like, ooh, how can I maybe increase my yield or, things like that. So it's going to be exciting.
If you're good to the soil is going to be good to you. You treat the soil right, your products, your yield, the quality of the product is going to be good.
Yeah, that's a life lesson right there. If you put out good, you get good back, right?
Yes, and if you put stuff, if you treat it like dirt, then it's going to treat you like dirt. You're not going to get anything back from it. It's going to
not treat your soil like dirt.
No, the soil is not dirt, none at all.
Definitely. All right, we have a couple viewers on, so I'm going to say welcome again to all of our viewers. You are watching Siren Sundays, episode 5 from season 3, What's in Our Soil? And my lovely guest today is Dr. Will Gustave, and I will let him introduce himself. And just to put him on the spot, he speaks 3 languages, guys, one, of course, being English. So I'm going to let him say hello to you all in the other 2. Maybe you guys can guess which the 2 are in the comments, and then he'll tell you later.
Thank you, Lashanti, for inviting me again to your show. I'm very happy and I'm very thankful for you doing this. You don't have to call me Dr. Gustave. That's just for Monday through Fridays in the classroom. But on a Sunday afternoon, will be just fine. Yes, today I am going to talk about soil and what that means for our food quality. And as promised, I'm going to say hello in 3 languages, and then I'll let you guys discuss. So hello in English, and then alo and ni hao. I guess everybody else can guess what the other 2 languages are.
Yeah, we do have someone in the comments who said it before you even did it, Creole and Chinese. So yes, we have our trilingual friend on this call. And I will have you also just tell us what got you into soil. Why did you decide to study soil? How did you get there? Was it something when you were a kid playing around in the dirt, even though it's not good to call soil dirt? Tell us.
No, it's not. In fact, there's a very big, I'm going to start off by letting you know, there's a very big difference between the soil and dirt. The dirt isn't living. The dirt is just, waste. The soil itself is actually a very complex living system. And there's, if you treat the soil badly, then it will become dirt. But whilst the soil is living, it's not dirt. Very, very different. So how I got interested in soil. In fact, the story goes really far. In high school, I wanted to be an artist. So I did art and I studied craft. But a lot of my friends, they were in the, I went to government high. So they had the natural science program and they were in the natural science route. And I hung out with them all the time during lunchtime and after school. And they had chemistry classes, physics classes, and I just sat there. And I always thought to myself, well, chemistry and physics seems fun and it's actually easy. I can see bonds. I can see why they are formed. I can even predict how a chemical will behave. I just had this way of seeing them. I guess because of my artist background. And then after BGCSE, I didn't do too well in English. I never had a strong command of English. So I had to do college prep English, and I attended a local community college there. And it was there I met some of the best teachers I've ever had. I met Dr. Brian. He was a brilliant chemist. And I just decided that I'm going to continue with chemistry, and chemistry is what I'm going to do. And after completing the college prep program, I started my associate. I ended up doing my associate in biology with chemistry because there wasn't a chemistry associate degree. And then I met Dr. Mr. Bullet. He's an amazing biology teacher, and I was always so carried away how he walks into the classroom, don't use any book, never use any PPT, and just talk. And he was like the coolest biology teacher ever. And I was like, I'm gonna be like this guy someday. And it wasn't until I completed my associate degree and then went to UBM, met some of the best teachers ever. And they completely solidified that science was for me. I had Dr. Toppin, Dr. Stubbs, Woodrow Smith, Miss Nez. These teachers really shaped me and direct me into science. And I always said, I'm going to do something that is unique, that is useful, and I'm going to try to be a teacher, or at least half as good as a teacher as how these people were to me. And that's how I end up in soil. And I chose soil because one, it's undersubscribed, it's underappreciated. Many people do not understand how beneficial and how without the soil we wouldn't even be here today. In fact, without the soil, we all would probably die by 47 or earlier because the soil bacteria, Streptomyces, produce most of the antibiotics that we take today. And pre-antibiotic period, we died at around 47 years old.
What?
So it's actually added 20 plus years to our life expectancy. And without the soil, if we won't have food. So the soil basically providing all of the energy that it's keeping us going. Without the soil, we won't have clean drinking water because the soil filter most of the water. Without the soil, we won't even have a place to live because of the 25% of all the organisms that's living in or on the soil, we are part of that. We actually live on the soil. Our house, everything is on the soil. So imagine if it's damaged. So I guess all of these things brought me into soil and soil microbiology.
Yeah, and I think what you said is so important. Soil is really, I think the word you said, undersubscribed is the word you use.
Yes.
I think a lot of people, and I guess just like even just talking about how it's the dirt, right? Like a lot of people just kind of take for granted.
No, not dirt. That cuts deep.
It's not dirt, but even literally until just now on the show, to me, soil and dirt were like exchangeable, but obviously they're not. And I think just something as simple as that, a lot of people are not aware of. And I think, okay, I see a question that I'm going to pop up now before we move on. They say digging in the soil produces feel-good hormones. Have you ever heard this before? Is this true?
Well, I can't say it's true or not true, but I do know that the soil have a lot of beneficial microorganisms. And if you play in the soil, even though it might have some pathogenic ones, but if you play in the soil, you might become exposed to them in small amounts. So when you are exposed to them again, then you won't get sick. So if you're not sick, I guess you're gonna be a happier person, right? And it's the reason why Granny and grandfather always tell let the child go outside and play in the dirt. It's gonna make him or her stronger.
Mm-hmm.
So
that's true.
Yeah.
And I just think the activity of being outside and connected to the soil is also important. I know there was a documentary on Netflix that we had Dr. Selena Hubbard talk about. Oh, it's something that
Kiss the Ground?
Yes. That talked about, I had a feeling I would like that documentary, and I watched it after my episode with her, and I was just blown away. Just as simple as just the air, you breathing the air outside, obviously, like just touching the soil, like all these things you interact with, it just like psychologically, physiologically, just change the dynamic of who you are as a person and your body. And so I would say definitely, yes, digging in the soil probably does produce feel-good hormones just because you're doing something, you're focusing on something, and just being in the dirt, being in the sand. I'm going to also throw in sand because of the beach. It just feels good. Yeah. But so I know I'm thinking what's best to hop to. Can you say what you're currently working on right now? I know you have a lot of papers out, and I'm going to actually now pop in your Google Scholar profile so anyone who's listening can check out some of his papers. What's some of the stuff that you're working on right now?
So my research interest is basically very narrow. I'm interested in the soil bacteria, so the living the living part of the soil, and how it interacts with the non-living part of the soil. So how the soil bacteria interacts with the soil minerals and other structures that are in the soil, and how that interaction, how that relationship will affect food quality.
Right.
So that's what I'm working on. And I'm also working on how we can manipulate this to produce, sustainable energy. How you can make power from the soil. How you can use just the soil itself to produce electricity without adding anything else. By just
power.
yeah.
Oh, that's
So
exciting.
so that's basically what I'm working on, and what my research focuses on. I did share some slides with you. If you share the slide, maybe I can explain that, and it would make life a little bit easier. The second slide.
The second slide.
Yes.
Talk to me.
Okay, I'm going to try my best to explain this as easy as possible. You see, under normal condition, when the soil is oxygenated, so there's oxygen in the soil, many toxic metals that would give us cancer, for example, arsenic, and I'm going to use arsenic in this example, will be trapped on the surface of other larger metal like iron oxide, or the redness which you see on your soil as iron oxide or magnesium. And once they're trapped on the surface of iron oxide or magnesium, they're not available to the plant. This means that the plant will not be able to uptake these toxic metals, these toxic trace metals from the soil and store it in their edible parts. If you press. So let's just say you have a flooding event that happened, like for example with rice. You need to grow rice under flooding condition. So the soil bacteria now that will now dominate these flooded soil no longer have oxygen available for them. These bacteria have evolved. They have evolved in a way to breed metals. So they are going to breed the metals that are in the soil. And when they breed the metal, the same way we breathe in oxygen and breathe out carbon dioxide, when they breed iron oxide, they are going to change the state of iron oxide. This one solid iron oxide is now going to turn to iron 2 plus, which is a liquid. And all of the metal that was once trapped on the surface of this iron oxide is going to be released into the soil pore water. And then these plants are going to uptake these metals. And if we're using rice as an example, rice is going to store cadmium, arsenic in the grains. And cadmium and arsenic can cause many different forms of cancer. It can cause, for example, arsenic can cause liver cancer, bladder cancer, skin cancer. Cadmium can cause many different forms of bone deformities. So my research focused on how we can limit this release of these toxic metals, or how we can prevent this. And we have two main ways we're proposing two main ways we can do that. We can give the soil microbes an alternative. And these if they have an alternative, and if this alternative is better or just as good as iron oxide, these soil microbes will reduce this alternative, use this alternative, and this will definitely slow down the release of these toxic metals. And the second part of my study focused on how we can use our understanding of the metal biochemistry, and how these bacteria make these metals available and harvest that electron to produce electricity through microbial fuel cells.
Wow.
Yeah.
And what's also very interesting about your choice of topic and example, rice is big in the Bahamas. We don't grow it. We don't know. So a lot of people don't understand where it comes from, but we eat a lot of rice. And I'm actually a bit blown away by this, because I often wonder, do we really understand where our rice is coming from? And how do we know if we're getting the good rice? Let me know if you want me to go in the next slide too. I don't know did you still want?
No, that's fine. This one is just fine. Well, the majority of the rice we have are either coming from North America or Asia. And one interesting fact that most of us, we probably know, but we haven't realized that we actually eat more, either the same or more rice than Asians. Yes.
Really? Okay.
Either the same amount or way more rice than Asian. Now, if you look at the bag of your rice, right, it tells you that per day you're supposed to eat X amount of servings, right? And now you compare the amount of rice you get from Rwanda. How many
Oh,
servings do you think that is?
well, I already know our portion sizes are way out of control, but that's really interesting because I think we have a lot of health issues in the Bahamas, and you never really know where these things are popping up from, especially when it comes to things like cancer. And I don't want to start a conversation about that too in depth, but it's really important to look at what you're putting in your body. And rice, which is such a big part of our diet, it may have these toxins in it, which would have been fine under this normal portion. But because
Yes, and that's where I'm getting at.
rice, now I'm scared. I'm going to stick to yellow grits now. Like I think.
Well, yellow grits, then you have problem with cadmium and other metals. Remember what I said in the beginning. The soil is very unforgiving. If you treated it bad, everything that comes out of it is going to be bad. So the WHO would say if you eat less than 200, if you eat less than 200 ppb, which is about 0.0 ppm of arsenic, our body can tolerate that and get rid of it, right? But because our servants are so much, who knows what's going on? What's happening?
We having some uproar in the comments. We got some people shouting eat plants and other people telling us take it easy on the rice. So
rice is not the culprit there. It's us. We put these things in the soil, and we're causing this problem. So the next time you throw away your television, the next time you allow your old car to just hang out in your yard for years, the next time you dump out, you dump out anything that you're not sure what the content of it is, you really need to think about that, because you are adding things in the soil that's going to stay there forever. It is extremely difficult to remove. In fact, it's not even economically feasible to remove metals from the soil. You have to find ways to manipulate the bacteria, the microbes in the soil, to try to keep these metals trapped on the surface of soil minerals.
Wow. I think I'm just as surprised as you guys watching, because I know we do a pre-show talk, but I'm taken back. And I literally just ate rice today, so in my mind I'm like, am I okay? But I know we did have a question about these heavy metals from Shannon Yates. So does washing rice grains before cooking remove these heavy metals? Because I know I always hear, wash your rice. Does that help?
That's an awesome question. You see, we are under the impression when you eat brown rice, it's actually healthier than the bleached white rice. But the rice grain stores the metal on the outer layer, on the husk. So most of the metal is stored on the husk, and then the next layer, then you have metal storing. So brown rice contains way more metals than white rice, because white rice has been polished, the husk has been removed. So if you soak your rice overnight, you will definitely leach more of this metal out of your rice. But the problem with that is, when you do that, you also throw away all of the nutrients that is in rice.
That's very interesting. I know we have a question asking, is it the same for quinoa?
I'm not sure if arsenic is going to be an issue with quinoa. I think this crop grows in dry land, and because it grows in dry land, cadmium might be an issue, because cadmium is bioavailable under oxic condition. So when the soil is not flooded and there's oxygen in the soil, then cadmium will become bioavailable, and then these plants can take it up, and then cadmium can cause problem. And then you have your lead and many other copper and other trace metals that can definitely be problematic.
So we do have the question that I was going to ask as well. So are we in a lose-lose situation here with rice?
Well, we're not. You first need to make what's happening is because so many people eat rice. So many research have been done on rice and how to limit arsenic concentration in rice.
Okay.
So we can eat rice that are coming. Okay, I must say that yes, arsenic is in rice from North America, and arsenic is in rice from Asia. But the dominant species of arsenic varies from both countries. So there are inorganic arsenic and there are organic arsenic. Inorganic arsenic, very toxic. Your body can actually deal with it. Organic arsenic, less toxic, and your body can actually flush it out very effectively. So I would suggest you eat rice from countries that are known, if that rice is contaminated with arsenic, that it's contaminated with organic species of arsenic rather than being contaminated with inorganic species of arsenic. But you still have to eat rice based on the WHO recommendation. It's written on the bag. We can't just eat things how as we please. We have to follow
Agreed.
the yeah, we have to follow the instructions. There's a reason why they're there.
Yeah. And so I'm gonna pop this question up, but I almost like I don't want to get into calling out brand names, but we
Well,
have that one
I don't.
rice.
I'm not gonna.
No,
Soil scientists go missing all the time because of
no,
that.
but we got this one brand, with the little man on it, that we have the song for. Only. I'm wondering, is that not like how do we read the back and understand if it is like how do we get this research and find this information on whether or not this is better rice for us? Like if it has this inorganic or organic arsenic.
So
Help
the
me, help me continue eating rice, please.
So I think that we do have an organization. I can't remember the name of the organization, but they are responsible for food quality here. And I think they're doing an amazing job. And the only way you can find out, because we're importing our food, right? Those
Yeah.
companies can tell us anything. We have to do market surveys. You have to go out in the market, buy different varieties of rice and different brands from different countries, and you have to do the test, the measurements by yourself. And you target these different elements, and you see if the concentration are above the WHO recommendation or if they are below the WHO recommendation.
Man, you can't do that for your people.
I would love to do that. That's my passion. I'm obsessed with bacteria. I'm obsessed with metals, and really, I'm obsessed with rice. I did a whole PhD with rice. And the thing is, we are getting there at the university, but we still need to, we're almost there. We have a fully equipped lab. Once it's up, it's running, we're going to be able to produce these data. And we're definitely going to, well, in fact, I guess when we get to the part, how to get a part of the research, I'll tell you what I'm doing with students
Okay. Yeah.
at the university.
Yeah. So we do have this question here. And I think when I first met you, like maybe 2 years ago, I asked you this. Can we actually grow? First of all, can we even grow rice here? And can we grow healthy rice in the Bahamas based on your research?
Okay. So Dr. Stubbs is one of my faculty members, one of my models, one of the people who got me into science and in this direction.
Hey, Dr.
We
Stubbs.
can grow rice here. We have the climate is perfect. In fact, we probably can grow 2 or 3 different batches of rice. But in fact, I have a student now for her final year project. She asked the question, can we grow rice in the Bahamas, and which soil type would be the best soil type to grow the rice? So she's doing a greenhouse study where she got soil from different islands and different parts of New Providence from different inoculums and she's growing rice now. And and the data is showing that yes, we can grow rice here. Rice will grow quite well here in our soils. The only problem is you'll have to supplement it with some essential nutrients, and that's expected because our soil pH is very high, and many of these nutrients are not going to be available. And most of the soil came from New Providence. New Providence doesn't have the best in terms of agricultural soil.
Yeah.
When we were building our house, what we did, we took the bulldozer and we pushed the living part of the soil away, and we exposed the non-living part of the soil so we can have a nice foundation. and we then buy some more of that white curry and we pour it in our yards for beauty, and then we wonder why nothing wants to grow there.
That's so true.
Yeah.
Like,
So
she's
yeah. So she's trying to answer that question, and her preliminary results are showing yes, we definitely can grow rice here, and I strongly believe we definitely can grow rice here.
That's so encouraging. And I think one of the things I'm really proud of right now for our country, people are becoming more conscious about what we're eating. And also, we're starting to see this shift now where we're trying to grow our own food. So I could imagine a world where maybe one day we'll grow our own rice, you know?
Well, Ashanti, I have some very opposing views to that. I feel like if we are ever going to become a nation that feeds itself, we need to stop growing garnishing items because, let's be real. When last you put, I don't know, some
basil?
or some of those fancy lettuce on your plate? No, right? I mean, for me, no. We eat rice, we eat grits, we eat tulips. These things we eat in large quantities. We need to grow these things. We need to grow rice. We need to grow wheat. We need to grow corn. And only then we will be able to feed ourselves. I mean, you ever try eating a salad for dinner? For me, I get up at 4 o'clock to eat something else 2-3 hours later. It's simply just not enough. Yeah.
Wow. I know I see a question here when we were talking about the quality for the food. Is that the Bahamas Bureau of Quality and Standards? Is that what you were referring to earlier?
I'm not sure if that's it, but I know it's actually it's probably that come back. Yeah, that's it. Yeah, it is. It is.
Yeah. So I saw 2 other questions. I'm gonna shoot them now before we move on to the next bit. Is Epsom salts a good fertilizer?
I guess it depends on the concentration.
Okay.
We do have some of the essential elements that plants would require, but most of them, they would require them in very low concentration. So if you're trying to make your own fertilizer, you would definitely want to water it down a lot. And then again, you got to be very careful because you must first see what's in the soil before you begin adding more.
All right, and I know another asked about composting tips. I know we just talked about how, when you build stuff, you move the living part of the soil, we don't put it back. How can Bahamians maybe, or anyone listening, do this composting thing the right way to where you're having good living soil and not just some bad dirt? See, I'm learning.
Okay. So I'm all for compost when you're using plant material. And so the whole purpose of composting is to try to kickstart the soil microbial community and to increase the soil organic matter content. And that way, once you increase food, you'll have more microbial activity. And once you increase microbial activity, they produce all of the chemicals that are required to keep the soil together, trap soil moisture, and all of those stuff. So if you're using plants-based composting, it's fine. But you should be very careful when you're using animal waste compost like manure, because like us, you ever heard the saying, we are what we eat? So when we feed our chicken and we feed our swines antibiotics, right?
Yeah.
So inside of their digestive tract, they would have some microbes that are antibiotic resistant because these microbes were able to survive in them, right? And if we then use their manure, we add antibiotic resistant genes in our soil. And that, can cause a lot of problems because these genes now can enter into microbes that we were once able to deal with and give them traits that enables them to now, if you take tetracycline or any antibiotic, it's no longer effective. So that's something we need to be very careful of. And again, we feed chicken some processed feed that will stimulate growth. And these processed feed contains heavy metals, especially arsenic, that will stimulate their growth. So when you put that manure into the soil, yes, your plants will grow very well. In addition, you have also added heavy metals that these plants can now take up. So we got to be very, very careful about that, especially chicken from companies and swine, because the people want to make sure that their animals are healthy, right? You don't want have a chicken farm with everybody dying from a bacterial infection, so you're gonna pump in a lot of antibiotics. But in these chicken feces is gonna have a lot of antibiotic resistant gene, and then when you add it into the soil, you include these antibiotic resistant genes. And if especially if you're into raw vegetables, or you get some of that soil and you get infected with one of those microbes, then it can be very problematic.
Yeah. And I know we have another question about fertilizers, using seaweed as fertilizers. And I know I've heard about like when we get those big sargassum like washing onto the shore. And I've heard people say it's good seaweed. And I mean, good fertilizer. Is this true? And should we maybe in the Bahamas be trying to take advantage and capitalize on this?
I haven't done any work with seaweed, but I would assume that it is good because it would increase soil organic matter content. But I would also caution, because if you take a large amount of seaweed, those seaweeds have large amount of salt in it. And if you then take it into the soil, then you put yourself at risk for increasing the salt concentration in your soil. And that will definitely, salt will definitely increase in salinity beyond a certain point. Nothing is going to grow there unless they are tolerant.
Like mangroves. Clearly.
Yeah.
That's the only thing that you can use to grow in salty conditions.
Yeah, so you should be very careful. Make sure you at least leach out all of the salt out of the seaweed before you add it to the soil.
Okay.
So that's the problem with soil science, it's undersubscribed, so people don't really get it or understand how it works. So they see someone doing something and they just go and repeat it. But and that's another problem with us as scientists. We tend to only paint the pretty pictures. We tend to only tell the success stories,
yes,
but we fail to report the negative results.
Mm-hmm. And that's actually a couple months ago when I was doing my master's, one of the things that we talked about, and I think there's a website, conservationevidence.org. I'll try to find it when you start talking again. But it's so important to publish your failures in science, because I may think I have a great idea about, like you said, with this seaweed and soil, someone else might have tried that. And that could save me so much time if they publish their failures, because now I'll know, oh, they had issues with salinity. Well, let me leach the salt out first and see what happens. And that helps people build on the research. And that actually makes progress move a lot faster, because there's often a rush in conservation and science and in a lot of fields where I want to be the first success. But we can learn from each other's failures if we just, come together and do things together. That's a unity message for all the people out there.
I mean, that's the only way forward. Mm-hmm. It's the only way it's going to work. Like I said, if we just take things from one place and transfer it to another, we never know what's inside this material. You can basically just take in metals from the sea and bring it to the soil.
Yeah, which is a whole other bag of worms, which is good for the soil. But how can someone get involved with this type of research, whether it be something for students who want to study this, or even just your basic backyard farmer who might want to just be a little bit more versed in soil? Like how can people get involved with your work, or any future inspirations for people interested in studying this stuff?
Well, I'll start off with the future inspiration part, because I'm a very big advocate of trying to get people to move into the soil field. So soil is not only undersubscribed, not many people are doing work in it, but it's very lack diversity. Very few people of color and even very few females are in soil. So if you are interested in soil and you are interested in getting a degree or understanding the soil more, the chances of you getting a scholarship to do it is very high. It's in demand, it's undersubscribed. And there are a lot of scholarships that are actually tailored towards people of color or females, because the area is so not diverse.
Yeah.
And if you want to, this is just my personal opinion, if you really care about farming and you really want to be the best farmer that you can be, to first become a soil scientist. It will save you a lot of money on fertilizers, because you know exactly what to add, when to add, It will save you a lot of time and wasting, trial and error and trying to figure out which crop to put in the soil there. Or different soils will support different type of crops. Second part, if you want to learn about this locally at the university, we are actually doing a lot of work with that. We are trying to be more diverse. We are guiding students in more of these sustainable projects. So that's one way. We have a whole degree in small island sustainability. You can enroll in that. It's free, totally free. Tertiary education is totally free here in the Bahamas.
And because I don't think people realize that now. Everyone wants to go off to school, but it's free.
It's totally free. And the amount, I have never worked so hard for a degree as compared to the amount of work I had to do at UB for my undergrad degree. And that's facts.
I did a year there, and I was like, at the year I did at UB, I think my 4 years at my undergrad, in the States, I was like, wow, this is easy.
And that's the truth. And that's because we're very vigorous at UB. And secondly, even if you are in the bio program, we have a diverse team of lecturers. So for example, myself, in the soil. So every year, students who are interested in soil ecology, or any microbial ecology project, you can definitely work with us, with me. And I would take on these students, we will assign project, and we try to answer different questions. Like I said, one student is asking the question, what can the Bahamian soil sustain rice growth, and which type would be the best? And another project that I have a student working on, which type of soil would produce the most or the maximum amount of energy, which one to use? And she's using soil inoculum from lakes. She's using inoculum from mangroves, farm, urban, and degraded soil, and she's comparing all of this. I have another student that is going to try to establish some baseline for the soil total organic matter content on New Providence Island. And as we get more equipped, we will move into trying to quantify different metals or different soil indicators. So that's a lot. And you could always read, like for myself, I really believe in making science available and very easy to find. So every time we find something, we publish it and we make it available. So and if any paper that I'm a part of, if you should ever need a copy of it, you can just shoot me an email. I'm more than happy to do it. Right. Or, this has nothing to do with Siren Sundays. There's Science Hub. You can get anything you want from there.
What did you say? The Science app?
Science Hub. It's a party software that gets any paper for you free of charge.
No, that's totally fine. Science Sundays is all about bringing people into these sectors that we are no longer including people in, like conservation and environmental sciences like soil. But I wonder, you used the word, just to backtrack a bit, the student that is collecting what did you say the word was?
Soil inoculum. So it's basically a fancy term for that.
Write that down.
Yeah. So inoculum is just a fancy word for taking soil from different environments, from different settings, different environments. So, if you take soil from an urban area, soil from a farm area, soil from a pond, and soil or sediment from a mangrove swamp, the bacterial community is going to be very, very different because the environmental conditions are very different. So by her doing that, she would see which conditions will favor the type of bacteria that we are interested in, the ones that can transfer electrons outside of the cell, and we can harvest this electron, put it on a circuit, and produce small power.
Soil power. Yeah. That's so exciting. I am very, very excited to see over the next few years some of the progress that your students make. And I think I would even like to see maybe one day, and I'm going to spark this idea, I hope, in you, just maybe like a backyard soil scientist course where people who are obviously older, a lot of people can't go back to do a 4-year degree, or maybe just can't do a 4-year degree even now that they're younger. Just a quick course, like maybe even a technical course at BTBI that just you can make, just to kind of create even just a new kind of like job sector. You know, there are a lot of farms in the Bahamas. There are a lot of people who are great at farming, but if we could have just some like soil technicians, right, that understand the basics of the science, and then they can work on these farms. Hopefully maybe we can get it funded from a government agency, you know, that can then boost the productivity of the farms that are already established, and then even help create more higher yielding farms. You know, I think
Yeah,
if I could give you that idea and you can run with that, because you
that's,
heard it here first on
that's an
Siren.
awesome idea, you know. And I think if there's demand for it, I don't see any reason that will prevent the university from offering the course.
Mhm.
There, you know, my colleagues and I, there are more than enough expertise in soil and plants to offer these kind of courses.
So it sounds like you and I are going to keep talking about this, because I might even want to take this course just so I can know. But this would be nice. You know, I think maybe just like how they have all of this online learning right now based on COVID, if someone in their spare time while they're working from home can maybe take an hour a day, every other day for a couple weeks to then get a certificate in understanding soil science, and we can make kits for people. You know, great idea, right? We're going to run with this off record, and then we're going to maybe come back one day and talk about it. But I think these are the type of things that we need now. Like, everyone thinks that to be successful or to even be good at something, right, you have to get a degree. And I'm like the biggest proponent of that's not true. I always encourage people to learn wherever you can learn. You don't have to go and get a bachelor's degree. You don't even have to get an associate's degree. I highly recommend finishing high school, though, just because, you know, why not? But you do not need to have like a college education to be successful in even scientific fields. So I definitely think more technical courses, and even something like this, I love what BTVI is doing, will be wonderful. And I know some of the things we have left to just talk about is, so if someone wanted to just get involved in some of the work you do, like, do you have needs for people who just want to come and help collect data, collect samples? Like, are there ways that someone can just get involved to help maybe push this progress for your research or your students' research?
Well, okay, so I have my own personal research group, and
Okay.
my good friend Shannon has been pushing me for years now to name it the Gustave Lab,
Woo!
but it's
That
not
sounds really nice, though.
good. And in that lab, we call it e-biogeochemistry lab. So we study. It's a microbial ecology class. So based on what we understand about microbiology, how can we manipulate this to help one produce electricity, or help to make nutrients available for plants, or how we can use it to support sustainable agriculture where we don't have to keep on dumping the nutrients. We can somehow stimulate the soil microbial community to either retain the nutrients or make these nutrients constantly available for the plants, so we don't have to keep on adding synthetic fertilizers and stuff. So we do have a group. Now it's available to students that are doing their FYP, final year project. But
Okay.
anyone who's interested, anyone who's interested, shoot me an email. I would be more than happy to share anything I know with you. And I'm doing this because I was educated by the state. Every single one of my degree were paid with your tax money. So I have made it my mission, my business, to help anyone and share this knowledge however I can.
And we thank you for that, because oftentimes we don't know where our tax money goes.
Well spent, right? Well spent.
But I know we're about 45 minutes in. Please, guys, if you have any questions, shoot them in now. I know I have one before we start our wind down. We were talking a bit earlier before the show about this electronic waste and this burning of metals, and because the new ecology park. And just as a disclaimer, guys, I have not done any research into the ecology park. I just know now they're advertising that they're able to separate things. But I'm just curious, just in general, how do you properly dispose of electronic waste that I guess can no longer be recycled? Or because I know there are places that burn metal, I think. And what is that? Like, what is that doing? Let's talk about
Lashanti, this here is a question, and this is actually my next move forward as soon as we get our lab going.
another exclusive on
Deal with these electronic wastes.
Yeah.
So what happens here is that we have scrap metal companies that collects them. So let's say we bring some wires. the company is not going to pay me for the plastic component of the wires. So what they do, they set fire on the wire to separate the copper from that. But what people are not paying attention, or what we should be paying attention to, right, and we should be regulating, is that when these people are setting fire on these wire to set, to get the precious metals that they want,
Right.
what's happening to that soil? What's happening to all the metal that are leaching? And sadly, most of these recycling companies are located in the middle of urban areas. And no one is paying attention to that. And we should learn from countries like China. They no longer accept e-waste because, they have a province called Yiwu. It's totally damaged. They can't grow anything there because for years they used that to recycle e-waste. And now these soils are totally contaminated with heavy metals. And how to deal with them? I don't know. Stop accepting them. I listened to one of your shows a few, like Good Sundays ago, and the lady that was on said that we need to stop accepting things from people. We need to keep people accountable for it. I think she's in charge of the environmental and planning. I can't remember her name right now.
Is it Director Newbold at DEP?
Yes, Director Newbold. She made some very good points.
Mm-hmm.
It's always gonna get this from this country, and we're gonna get this from them because it's free. But they never, we need to make sure when we're bringing things in, we ask people, how are you gonna get rid of them? The whole big thing, solar power. But we should learn from Japan. They, the cadmium that are in these batteries, and we're not good at getting rid of stuff. Once it stops working, we fling it in the backyard for a few years. And if the Department of Environmental Health come and ask us to move it, we fling it in a mangrove swamp or something like that. We need to think about these things. We gotta bring in solar panels. We're encouraging people to do that. How are we going to dispose them?
Yeah.
What are we going to do when they start leaching? What toxic heavy metals are in there? And if they should get in the soil or in the environment, what are we going to do it? So these, there's a lot of things we need to think about. I don't have all of the answers. I would love to, but I just don't have the answer, and it's very scary.
See, and I'm glad you touched on that. And I'm going to use a little plug right now to talk about my island cleanups. I have another one happening this Saturday, and it's so crazy to see people just dropping refrigerators, washing machines, dryers, cars, jet skis, lawnmowers. These are the types of things, I promise you, I've seen it for myself. We still are trying to remove all of this waste from the Coral Harbor Canal area, but I'm just like, is it that we don't know what to do with it, or is this just what we do with it? And the fact that you just mentioned that it is sitting there and the canal is right next to the water. We use the water. It's above probably some freshwater lens where we are pulling water from to use. And it's like people, I don't know how to start connecting people to that. Like we need to figure out better ways of disposing of all of our waste. But now relevant to this topic is those waste, like those appliances.
Yeah.
And I didn't even know until you said it just now with solar panels. I didn't even think about.
They are very dangerous. Very, very dangerous if you don't dispose them properly. They are full of heavy metals. But the difference is, you see, if it's air pollution, we are going to see cloudy skies, gray skies. We're not going to like it. It's displeasing to us.
But and to tourists, and you know to tourists.
Yeah. But with soil pollution, it's like, having a gray shirt. You don't need to wash it every day. It's not going to show the dirt. Right on, right? And the same thing happened in the soil. We don't see the metals.
That's a good one.
Because we don't see the metals, we don't see the problem there. And a lot of people will tell you the soil is supposed to be dirty. And they just don't understand that this metal is going to get to you. It's going to get to your table somehow. And if it don't get to your table, it's going to get to your drinking water, your bathing water, somehow. And I think once we start to educate people about that, we start to educate people about the mechanism, how these things are released in the environment and how they can move, how they are transferred in the ecosystem, and they can see how it gets to their mouth, then people are definitely going to do better, especially if you start linking stuff with diseases that we have here.
So is it that, and I know someone made a comment earlier about eat plants, is it going to get to the point where even eating our plants won't be safe? Or is it just things like rice?
If we continue to treat the soil like dirt, the soil is not going to produce any food for us. So unless you bring your plant in another medium, ain't gonna be none of them there. And the ones that would grow will be either hyper accumulators, and you don't want to eat them. They're very smart plants.
Can
They
you
can
define that?
everything in the eatable parts to kill the next person, not to kill them.
What is a hyper accumulator?
So a hyperaccumulator is a plant that can tolerate high concentration of a particular pollutant. And it's able to do that because it have learned how to either transform this pollutant into a less toxic species, or it has, like, for example, rice. It's stored in the grains.
Oh, hey, they'll eat that. Give that to them.
Someone else wrong.
Listen, and I think that's so crazy. A lot of people look at plants like, oh, like that, almost like they're not living, right? I mean, we get that they're living, but they're not making noise. They don't scream when we cut them. But I remember distinctly a movie that I think it was The Happening, where all of a sudden people were like dying, and I won't get into too much detail because it's pretty graphic. But they found out that what was happening is the plants were basically pissed off at us and started secreting hormones into the air to start basically outing the human population. And I'm just like, people don't realize that something like that could probably happen. Like, listen to what you just described.
It does happen. I have a classmate who did he also did a PhD in environmental science, but he's studying the release of air pollutants by the pine forest and how they release so many organic pollutants that are causing so much problem and contributing significantly to global warming.
I'm a head out. What? Okay. Wow. Wow. That's crazy. So I think we definitely need to get a jump on this. I see we have another question. Let's just get to that really quickly. How do you feel about agroecology in the Bahamas? From our wonderful
I think agroecology is the way forward, because one of the reasons, and it's sad, but one of the reasons our soils are dying is because we have transformed our forests into croplands, right? And doing that kills the soil because we rape the soil. It's like you overworking it without doing nothing to it. So if we adopt agroecology or agroforestry systems, we get to keep the soil, you get to keep some part of the forest, and then the roots of those plants, the community that was already established with these plants remain, and then you grow your crops. And you grow your crops in a particular way where you rotate them, or you practice, you grow more than one different type of crops, and that kind of prevent your soil from being degraded or eroded, or at least slow it down significantly. And if you're doing that in a sustainable manner, you can create a cycle where even though when you remove your crops, you eat the parts that you want, you return the remaining part, and it puts back the organic matter, puts back some of the nutrients, and you don't have to worry about adding synthetic fertilizers. And not only would you get better crops, you'll get a healthier soil. And if you get a healthier soil, you'll have higher yield, and you'll save a ton of money from not having to keep on buying synthetic fertilizers. They're expensive. You ever try to buy a bottle of Miracle Grow?
No.
It's literally like this size for $30.
I unfortunately was not blessed with green thumbs, so I hope to either continue letting my dad do all that work for me, or finding someone who could do that for me, because these thumbs, I kill every plant that I try to raise and grow, except aloe. Aloe has been the plant of life for me because it will survive.
Well, but don't touch that mango tree.
You straight. Yeah, you straight. Especially because thank you so much for doing this episode. I'm going to definitely bless you up with all the mangolas that I get this season, or most of them, not all. But can you, give some advice and some final thoughts, as we come to a close for this amazing episode? This has been so great. What would you give advice to youth specifically, and then to the general public, about everything that we've just talked about? What are some sticking points you would want to leave with people?
Okay, so the biggest advice I'll give to the youth is, if you're going in science, do not try to be a jack of all trades. You find an area that you like, and then within that area that you like, you find a small portion of it and you only focus on that and become the best person in that area. When you try to do everything at once, you're not going to be good at anything, and quite frankly, you're not going to be taken serious because we can't be good at everything.
No.
And I think that's the biggest problem we have here. You would hear people, they have an opinion about this, they have an opinion about that, they have an opinion about this, and you ask yourself, how is this your field? How are you even qualified to be saying that? And you see the problem we have with that, even in the medical field.
Mm-hmm.
And the second advice I would give to them is there is more to science than just the medical avenue. There's ecology, there's agriculture, with that's where we need to be going in. Of course, there's soil science, and all of these things are interrelated. So we can definitely go in that direction, push forward, find your niche in that direction. Then you don't need to be competing for the one job that's there for that particular thing, right? Because you're the only one that has it. And the third thing is that whenever you find out something, share it. And that's another problem we have here. I've been trying to get data. I've heard people say, we've done this, we've done that, but where is it published? Can you send it to me?
Yeah.
No, there's some restrictions. Then what's the point of collecting this data if it's just for you, right? Yeah. So share whatever you get with people. If you come across a paper, share it on your social media. If you have some good data, share it with people, and at the end, it's going to benefit all of us. Also, share, like you mentioned earlier, share your failures, because it's important to do so.
Yeah. And I think just on that note of sharing, I saw this post on social media, right? Anytime, like sometimes you've been doing research and people like stumble across a paper, but they realize, locked, no access, blah, 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 blah. I saw a post that said, if you can just figure out who the lead author is, they'll be more than happy to send you an email with that PDF. Is that true?
Not only would we be more than happy, I give students A all the time. They sign a paper and say, Gustave, and I'll send that. If you ask me for my paper, it's like the best, the greatest gift you can give a researcher.
Oh, wow.
Because normally the first author on a paper is normally a student, right?
Yeah. Wow, yeah.
Normally a student, and this student is just starting out. You can imagine you send them a message asking them for their work. It shows that people are listening, people are following what you say, and so most of the time they would give you that paper. If you email them, they will give, especially for me, I'll give you the paper. If I don't have the paper for myself, I'll use other means and I will get the paper to you. And it's one of the highest form of flattery you can do for a scientist is to ask them for that paper.
That's true. And I'm sure even a lot of scientists, maybe even including yourself, would love to even have a conversation about it as well. Because like you said, it's good to feel like the work you're doing, even if it's just one person has actually been received and someone is actually taking that into action. So guys, check out his profile. I shouted in the comments. Email him. He's answer email quick too. So yeah, but thank you so much. I don't see anyone. Let's see.
Thank you for inviting me.
Yeah, definitely. So for everyone out there watching, thank you for enjoying another episode of Siren Sundays with us on this beautiful Sunday afternoon. Thank you so much, Will, for doing this. I think this was such a great topic to have, simply because, like you said, not a lot of people understand soil. It's so undersubscribed. I mean, I was calling it dirt. And I hope, I know. I hope everyone listening, whether you watch this live or you watch this later on, stop calling soil dirt. Stop saying I'm looking for dirt. Dirt is dead. We want soil. We only about living, positivity, not the death, not the negative. So again, remember we are all connected, not only to each other by the ocean, but obviously by the soil as well. So let's be sure to make conscious decisions, live a little bit more sustainably, small steps to a big change. Thank you for tuning in to another episode of Siren Sundays. I will see you guys in another week. Bi-weekly, not next Sunday, but the Sunday after. Have a great day. Thank you so much, Will. Bye.
Bye-bye.